Welcome back to day 2 of our statistics part 2 unit. All right, for today, we do have our goal of the day. So today, given a set of bivariate data, you will be able to graph a scatter plot and determine if there is a correlation and or a causation between the data. All right, first, we have to graph the scatter plot. All right, so let's go ahead and take a look. All right, so a scatter plot. A scatter plot is a useful summary of a set of bivariate, which means 2 variables, of quantitative numerical data. It can be used to check to see if there is a relationship between the data. So if I take a look here, we have our data, we have numbers. Okay, so that's why it is quantitative. And then our points are just plotted using your X and your Y, your coordinates. All right, so let's go ahead and let's take a look at our first example. Marissa and John did a study on the amount of fat and calories in food products at McDonald's. Below is a chart of the calories and fat that are in different foods. So part A, we're going to draw the scatter plot of the findings. So if we take a look over here at our chart, here's our bivariate data. We have 2 sets of data. All right, so your total fat, this is our X variable. Now your X's are also known as your independent variables. So independent variable. Okay, and the second column, these are going to be your Y values. These can also be noted as your dependent variables, because the variable, the Y, depends on the X. All right, so let's go ahead. We need to create our scatter plot. All right, so our independent variable, your X, is going to go along your X-axis. So down here, we're going to have total fat. Okay, so let's take a look at your X value. So if I take a look here, we have our smallest X is 5, so this is your minimum. And your maximum X value, it looks like it is 34. Okay, so we're going to have to extend our X's from 5 to 34. And if we look at how many spaces we have, all right, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, we're not going to have enough if we count by 2s. So instead of counting by 2s, I'm going to count by 3s. So 0, 3, 6, 9, 12, 15, 18, 21, 23, 24. All right, then we have 27, 30, 33, 36, and 39. Now let's look at our dependent variables, our Y variables. So these are your total calories. So I'm going to label my axes, total calories. And now I have to come up with my scale. So I'm going to look carefully at my chart. My lowest calorie is 260, and my highest calorie is 590. All right, so if I have to go from 260 to 590, well, the first thing I'm going to have to do is put in a break. I'm not going to be able to start counting at 0. All right, so 260 to 590, I think I'm going to count by 25s. So I'm going to start at 250, and I'm going to go up by 25 each time. 275, 300. Okay, now that I have all of my scales, I can start plotting my points. So my first point is 9 and 260. So I'm going to go over to 9, go up to 260. So 260 is going to be between 250 and 275. I put my point, and then I'm going to check it off. Okay, next is 13 and 320. So 13 is going to be between 12 and 15. Then I'm going to go up to 320. That's just below 325. And I put my point. Okay, and check that one off. All right, so go ahead, hit pause, and continue graphing all of your points. All right, so here we go. We have our finalized scatter plot. Okay, so part B for this problem says, does it look like there is a relationship between the amount of fat and the amount of calories in the food at McDonald's? So take a look at your points. Do your points form a pattern? So does it look like your points form a pattern? So if you look, it kind of looks like as fat increases, the calories increase. It looks like we have a relationship there. So is there a relationship? I would say yes, there is. The more fat is the more calories. So yes, the more fat, then the more calories. Oops, then. Okay. All right, so that was part 1 for today's lesson, which was to graph a scatter plot. So now let's take a look at part 2. Determine if there is a correlation and or a causation between the data. All right, so let's flip the page over here. All right, so the first word we have to learn is a correlation. Now, a correlation, if you look at the end of it, it is a relation. So a correlation is two measurements that are related. Two measurements that are related. Okay, the way you can tell if there is a correlation, okay, is you will have a scatter plot that follows a pattern. Okay, so let's take a look. A linear correlation is what we're going to be specifically looking for. A linear correlation is when the data points in a scatter plot form a linear pattern. So here are your different types of linear correlations. If we look at our very first plot, okay, it looks like the points are forming a linear pattern. I could draw a line to follow the pattern, and this is going to be a positive linear relationship, because the line has a positive slope. As one increases, the other increases. If I take a look at my second scatter plot, and I look at the pattern of the points, it looks like the points are forming a pattern of a line that goes downwards. So this is going to be a negative linear correlation. Now, if I look at my third one, the points are completely scattered. They are all over the graph. Okay, when this happens, there's no pattern to be seen, which means there's going to be no correlation. There is no relationship between your independent and your dependent variables. The second word that we have to familiarize ourselves with is this word causation. Now, a causation is when you have a correlation, but it's not just a relationship. It's when two measurements are related because one causes the other. So two measurements are related because one causes the other. Okay, so an example of a causation. If we go back, to our relationship of our scatter plot, we have total fat and total calories. Now we saw this formed a positive linear correlation. But now let's think. If you have more fat, does that cause the food to have more calories? Well, let's think. I believe for every gram of fat, there is a specified amount of calories, so yes. the more fat causes the more calories. Okay, so let's take a look at a few different examples and see if we can decide if there is a correlation or if there's no correlation, and if there is a correlation, if it is a causation. So I know that's a little tricky with the wording, so warning, a correlation does not necessarily mean a causation. You have to look very carefully at your two variables. So just because there is a strong correlation between data does not necessarily mean that one set of data is causing the effect that is occurring in the other set of data. So let's look at the scatter plots and decide if there is a correlation and if the correlation is a causation. So number one, miles driven and gas used in the car. So look at the points. Do the points form a pattern? Well, it looks like they form a positive linear correlation. So let's write that down. Positive, oops, you can't see that. So positive linear correlation. Okay, since it is a correlation, now we have to think. Does driving miles cause you to use gas in your car? The answer there is yes. So this is a positive linear correlation and a causation. Okay, now let's take a look at number two. Reading score versus shoe size. Well, let's take a look. If you look at the data, does the data form a pattern? Well, it looks like it does form a linear pattern. As one goes up, the other also goes up. So this has a positive linear correlation because it follows a pattern. Now we have to think, is this a causation? Does your reading score cause you to have a different shoe size? Well, the answer here would be no. So there is no causation here. These are not two things that cause each other. All right, so let's take a look now at number three. Number of problems missed on a test versus the hours that you study. So if I take a look here, if I look at the points, do they follow a pattern? Well, it looks like they follow a line that goes downwards. All right, and since it's going down, this is going to be a negative linear correlation. Now, let's think. Does one thing cause the other? So, your hour studying, okay, so if you study for many hours, is that going to cause you to miss less problems on a test? Well, the answer there is yes. So if you study more, it's going to cause you to miss less problems and get a better score because you will know the information. So, and causation. So one thing does cause the other. All right, so our goal for today, given a set of bivariate data, you will be able to graph the scatter plot and determine if there is a correlation or a causation. All right, nice job, everyone. I'll see you in class.